first thing that would be required for the operation system would be the ability to project 3D elements out of the screen into a space that could be freely moved through with your hands. The second element would need to involve motion sensing hand recognition technology, such as that used in the Xbox Kinect. With the emergence of new interactive 3D possibilities, there could be a need to reevaluate how the folder systems function. When we consider the possibility of using motion sensing hand recognition technology to allow us to manually manipulate projected 3D digital objects, we also need to look at introducing new ways of storing these 3D files. If the files are 3D projections, it could be beneficial to have them stored in a digitally projected 3D environment. When the 3D objects are projected into the interface space, the system would recognize the position of the user's hands and allow them to interact with the projections. Some of the interactions could involve turning, manipulating, bending, separating, breaking, and attaching projected objects. The beginning of a folder system starts with a desktop. This is essentially a root folder within which all other folders exist. In this case, however, it will be the branch upon which all folders exist. The main structure begins with a rod. It's a length of three-dimensional, digitally projected solid shape. It can be as long as is needed. The rod can be stretched to become larger, or rather to allow us to see it more closely. The folder rods can be shrunken as well, but would be beneficial to not become so small that can no longer be grasped. It could be rotated and moved around, held, and released. The lack of virtual gravity upon the object would be essential to maintaining it as a free-floating solid. If there were any gravitational pull upon the object at all, it might be beneficial to have its gravitational center in the center of the 3D interactive space to keep it from slipping off screen. Because the rod is free-floating, it would seem to lack a sense of orientation. In response to this issue, the rod's given a tapered structure. Both ends of the rod taper and become thinner towards the tips. One end is tapered shortly, while the other is tapered in a longer fashion, providing a sense of orientation for the user. The short end is the bottom and the long end is the top. This design feature makes sure that the user will always be able to tell the difference between one end of the rod from the other. From this rod, two types of things will be connected. The first will be other protruding folder rods, and the second will be orbiting files. Any desktop or root folder needs to be able to house more folders. In this example, we see a root folder that houses 4 subfolders. Each of the subfolders is essentially identical in structure to the root folder, except for location and relative size. All subfolder rods will be attached to their containing folder rods by the thick lower portion of the rod itself. They are attached so that there's enough length of the rod at the base past the containing folder rod to be able to grasp it with your fingers. The scale of any folder rod is controlled by grasping the ends, base and the top, and either pulling them further apart or pushing them closer together. Pulling them apart will increase the folder size, pushing the ends together will shrink the folder. The folder that's being grasped is always the folder in use. If you, for example, were grasping the root folder and want to access one of its subfolders, you would start by manipulating the root folder until you located your desired subfolder. Once you see the subfolder that you want to access, you would release the root folder. The folder system would remain stable and unmoving when not being physically interacted with. You then grab the ends of the subfolder and scale it up by pulling the ends away from each other. As the subfolder increases in size, so does both the root folder and the files and folders housed in that subfolder. Any folder that's part of the path to your currently accessed folder, in this case only the root folder so far, and any other subfolders of the same group will lose an amount of opacity. Containing folders can be re-accessed by shrinking the subfolder until the root, or containing folder, is small enough to be grasped. You could then grasp it and be back at the beginning with its opacity fully restored. The files in this system are not in folders, but are rather around the folder rods. With the files, like the folders themselves, everything works outwards instead of inwards. If the size of the folder rod is pushed to its limits by the amount of files around it, or folder rods attached to it, it simply elongates to accommodate more. All the general folder options are accessed from a button on the top end of the folder rod. These include creating a new folder, accessing info about the folder, viewing style options like file and subfolder display arrangements, other view options like backgrounds, spacing, text size, text arrangement, a cleanup function, and arrange by order organization options. The text should always ideally be upright and horizontal. The subfolder titles sit on the containing folder itself. They can always stay upright by constantly revolving on the folder rod. There are a few different things that we do with files. One is that we load them and use them in a particular program, or activate them to start a program. Another is that we can open a menu attached to them in order to access different options. These options can include controlling the way the file icon is displayed, what program to open it with, changing its name, deletion and compression, accessing information about the file, or duplication and copying. There are two main ways that a file icon can look. One is a flat floating 2D icon, and the second is a dynamic 3D icon. Even the 2D icon would operate within the 3D space of the filing system, but the 3D version could take further advantage of what's being offered. A good use for a 3D icon as part of the 3D filing system is that there could likely be a lot of relevant information on different sides of the 3D file. Being able to see all its sides and structure could be beneficial for its identification. You could spin or rotate the file without having to open it. The placement of the text in relation to the file icons should also move constantly to accommodate for the rotation of the folder bar orientation. This assures that no matter what way you spin and rotate the folder bar system, the file icon's titles remain upright. There are different ways that the folders can be arranged. One thing that stays consistent is the way they're attached to the containing folder, near the base. One way that they can be arranged is vertically, all the way down one side of the containing folder. A second method could be to arrange them fanned out around the y-axis. This arrangement is limited by the fact that the containing folder is generally skinny and can only accommodate as many subfolders per fan arrangement as can fit per fan section. Both the top and bottom need to be projected from the containing folder rod, and so only an odd number of folders could exist within the same fan if they're spaced evenly around the containing folder rod. A third option is to spiral them around and down the rod like a spiral staircase. This would take up less room than the straight vertical method, but not have the numerical issues of the full fan. The fourth option would allow the user to customize their own arrangement style. Wherever you created or placed a new folder would be where it would stay. Some people think very differently than others, and customizing their own arrangement method could accommodate for these differences in interests. File icons can float freely around any number of orbital paths. They can float lightly about or be fixed to a strict location in relation to the containing folder rod. They can be arranged in vertical rows or orbit on circular paths horizontally. The pattern could even pan downwards in a spiral. They can be close to the rod or further apart and away from it. They can also sit as closely together as the user decides to arrange them. They can be set to float at random or follow a strict orbital path. There are some other arrangement options that can be assigned to a group of files connected to a folder rod. One is to create leaves that fan out from the rod around the y-axis, like a Rolodex. Another is to have disks that sit in the folder rod that you can slide out. Another is to have no icons at all and have the files represented purely typographically. You could also have poles that hang the icons out like street signs. When it comes to customizing your folder options, the rods wouldn't be complete without the option to fully decorate them. This could include anything from simple textures to fully 3D rendered desktop folder decoration styles. This could help to distinguish folders from each other and also add a little personality. Although there may be more ways to work with these folders and options, this film covers the majority of the essentials. It allows a user to physically handle a folder system within a projection-based 3D user interface. It takes full advantage of some great opportunities of digital interaction and looks at a new way to organize and store information, folders, and files on a desktop. There are always circumstances where using a 3D folder system would likely not be the most efficient search method for finding a folder or file. There are, however, many times when it could be of valuable use, particularly when dealing with 3D files that contain 3D information. This system takes a decades-old filing system and not only adds a third dimension, but also reinvents the idea of containment and location association. Although the technology required for this system to operate is, to my knowledge, not fully actualized, it is being explored and will likely enter into our technological vocabulary of interactivity before long. Although this is only a design concept, the arrival of the necessary technology will invariably make it both applicable for 3D file storage and a valuable exploration of the potential of 3D projection interactive computing.